Hello. Hello.
The stage is
Pleasure to
yours.
meet everyone. Thank you. Thank you. I'm going to go ahead and try to share my screen here. If the host can just enable screen sharing, that would be good.
Okay, give us a second, please. Yeah, it's okay.
Beautiful. Thank you. Hello, everyone. Thank you so much for welcoming me to your community and your meetup. It's always great to see things like this. My background is Polish as well. It's a pleasure to see everyone. Okay, I'm going to be talking today about offensive GraphQL security. A little bit of background into who I am. So as mentioned earlier, my name is Nick. I'm the Chief Hacking Officer for ASEC. I'm also the author of a book that is dedicated towards breaking GraphQL and its security, known as Black Hat GraphQL, and I'll talk a little bit more about it near towards the end of the presentation. And there's my Twitter link for folks who want to follow me. So what is everyone going to be learning today, and what is the main thing that I want folks to get out of this presentation? First and foremost, what I wanted to share is that the old way and the traditional way of approaching security for our web applications and our traditional REST APIs is not efficient for protecting our GraphQL applications and workloads. Secondly, I want to talk a bit about how hackers approach GraphQL and how they break into GraphQL applications. And then third, I want to give some familiarity and give the power that hackers use to break GraphQL into the hands of each and every one of you as developers and folks who maintain GraphQL systems. And then third, I want to hope that we can implement these security testing tools into the way that we build GraphQL applications, such as our CI/CD pipeline. And then at the end, give folks resources and time to essentially ask me any Q&A questions. So traditional security tools in GraphQL. First and foremost, the tools that we are all used to that protect our REST API systems come up a little bit short when we try to protect them against protect GraphQL APIs. For instance, certain WAFs, web application firewalls out there, monitors, rate limits. These things are not optimized for GraphQL payloads and effectively come up short when we need to protect our GraphQL payloads. Many of these applications are effectively looking at things like status codes, the number of requests that we are sending to the particular system. So, for instance, if you're trying to block something like login attempts against your API, a traditional WAF may look at how many 401 or 403 errors am I looking at, and those will essentially let us know if someone's trying to brute force or get access to some of our users' accounts. But that sort of logic doesn't really work for things like GraphQL, where typically the status code of 200 is usually what you would see, and all requests go to the single GraphQL endpoint. As developers, we rely on these security controls to protect our applications, and we need to think of ways to change them or adopt new security tools to protect our applications. If we also look at some of the anomalies that pop up in the data that we gather, some of the things that GraphQL does is it puts a lot of the power into the consumer or the client. Essentially allowing them to batch certain requests in aliases, et cetera, that make it really hard for you to actually uncover what kind of requests are being sent to our applications. So a lot of the ways that we are approaching security in the space of GraphQL is really coming up short. And I want to talk about some of the tools that we can use to test our own production GraphQL instances to see how secure they are truly. So the very first one that I want to go over and talk about is clairvoyance. So going back a little bit, a lot of folks talk about introspection. And introspection, for those who don't know, is essentially a supported GraphQL query that you can make against the schema that will unlock information about the GraphQL schema within the application. This will highlight things like what kind of queries can you make, what kind of mutations can you make, and what kind of fields are associated with it. Now, most of the time when I do offensive security testing or audits for GraphQL, these particular introspection features are disabled in production. And a lot of folks ask me, hey, Nick, do you think that when GraphQL has introspection enabled, is that a poor security design or is that a potential vulnerability? And the way that I approach it back is, let's say you have a bank, you're trying to protect this bank. Would you want to share the blueprints for that bank with someone? Now, inherently, just sharing the blueprint for that bank doesn't necessarily make it secure or insecure, but it does give the potential robbers a lot of information about where potential vulnerabilities or weaknesses may lie. So most of the time we have introspection disabled in production. Now, as an attacker, that's unfortunate because I want to learn about the schema. I want to find out what those vulnerabilities are and where I might be able to inject malicious code into things like mutations. So how do we get past that? Well, the first thing that a lot of hackers against the GraphQL system look at is for a native GraphQL feature known as field suggestions, and this is supported by most implementations that are out there. And essentially, it allows for any consumer or client of the GraphQL API to send typos or weird fields to the GraphQL server, and the server will look at it, and instead of sending back a 400 request or an error saying, I don't understand what you're trying to request from me, like most REST APIs would, GraphQL servers will actually respond back very friendly to a customer saying things like, you sent me the letters PAS. That's not really something you can normally query for based off of my schema. Did you mean pastes or paste? So it'll actually give information about the schema back to the client in a very friendly way. Now, obviously, that's a great user experience for customers and new clients who are trying to use your API. But how friendly do we want to be with a potential bad client, such as a bad actor or a hacker? So that's exactly what Nikita and Ilya built here with the tool called Clairvoyance. Clairvoyance will essentially take a word list and automatically brute force a bunch of different types of words against a GraphQL topic or a GraphQL server to unlock what the schema might look like. So it's a very, very great tool and something that abuses the field suggestions. This is something that I would highly recommend folks look at and see if you see a lot of requests coming into your GraphQL server, especially if you're seeing like a bunch of weird words coming in. They're probably using a tool like Clairvoyance to try to see what your schema looks like. They're trying to extract your blueprint. As you can see here, we've built an application called DVGA, Dan Vulnerable GraphQL Application. It's essentially an app that has a bunch of vulnerabilities in it, and we'll talk a little bit about it in a bit. But on the left, you have the full schema for DVGA. You can see it's got a bunch of paste objects, owner objects, users, audit, queries, and on the right, you can see what Clairvoyance was able to extract based off of, I think, like 30,000 English words. So it's actually uncovered a lot of the blueprint, not a full set, but based off of those 3,000 English words, it found a good amount. So the next tool, keeping on the topic of brute forcing, is another tool here called GraphQL. Now, GraphQL is a tool that I built, and I must say it's probably the best and the most efficient GraphQL brute forcing utility out there. GraphQL essentially takes advantage of aliases in GraphQL. So all GraphQL implementations support this concept known as aliases. So in a single query, you can actually specify an alias for how you want your data to be returned back to you. And you can send one HTTP request and have a bunch of nested queries in there and get back in response a whole bunch of data. Now, what GraphQL does is it essentially allows you to do things like password brute forcing, user account enumeration, OTP brute forcing, IDOR or BOLA based attacks. The way that it works is that it effectively, the next slide, allows you to take a input, such as like a bunch of usernames and passwords, and apply them to a query, the GraphQL query. And in this case here, you can see that we have a mutation that is logging in. And in response, it will expect an access token. And here you can specify in the curly braces the inputs for that CSV to go into that GraphQL query. And then what GraphQL will do is that it will programmatically generate the query to send to the server. And here you can see, based off of these 3 inputs for username and password, the query that GraphQL will create will look something like this, where we have alias 1, alias 2, and alias 3 with the username and password combination. Now, obviously, it can send more than just 3 inputs in a particular request. And you can even, if you wanted to, fly under the radar for a lot of GraphQL controls, such as rate limit controls or query depth or complexity analysis. And you can actually batch the number of requests that you want to send. And as a response here, you can see that you'll get back a huge dump of data as well as errors. And you can see here that alias 3 had all of the correct credentials to get the access token. So it's a really, really great brute forcing tool. I highly recommend you look at implementing this against your own GraphQL applications. So the next one here that I want to also talk about that we built is called the GraphQL Threat Matrix. Now, I know that there's tons and tons and tons of GraphQL implementations that are out there, some for Ruby, some for Java, some for Python. And what we've done is we decided to put together our research for investigating all the different GraphQL implementations and put together a bit of a table that highlights some security considerations for each of the GraphQL implementations that are the most popular that are out there. And we put it into our GitHub here. As you can see, the list has about I think roughly 20 or so implementations, a little bit more, give or take. And some of the things that we're tracking for and we're looking at are things like the number of validations that are inside of that implementation, whether or not field suggestions is enabled by default or not supported. And as you can see, most implementations, they do have field suggestions enabled by default. Whether or not they have certain security controls like query depth limits or cost analysis. Again, this is really important for looking at things like brute force or other types of queries that are coming in that are trying to get a lot of information or trying to even potentially DDoS your GraphQL server. So you can see that a lot of implementations don't have things turned on by default. APQ, introspection, debug mode. So we track a lot of different things for each of the implementations that are out there. Now, there's a lot of tracking out there for sure. So it's a lot of work, and I welcome any PRs that folks would like to submit to the project. But some of the main things that I really wanted to share with the community with this project in particular was to give developers a tool to essentially measure how secure by default their implementation is. Is it pretty secure? Is it not very secure? And if so, like what are some of the things that I should turn on or turn off to make it more hardened? And then from a security or a hacker's perspective, we built this tool because we know that GraphQL is something that's relatively new to the security industry, and we wanted to give bug bounty researchers and hackers a bit of a launching off point to identify, once they've identified the GraphQL implementation that is behind one of their target servers, that they can now start to investigate and see whether or not certain features are enabled or disabled so they can launch further attacks. So it's really a tool for both offensive and defensive professionals. Drilling into one of the implementations here. So when you click on one of the implementations, you'll get a detailed view of that implementation, a little bit of information about it, what language it's in, where you can get the source code, where you can find documentation, as well as a bit of a deep dive into each of those features that I said is either enabled or disabled by default. And here you can see the Apollo implementation here has these features enabled and disabled by default. I also recommend folks look at the validations that are supported by their implementation, and that's shown in this table here. Now, a validation is essentially GraphQL's way of protecting itself or ensuring that queries that are coming in aren't going to go against any of the GraphQL specifications rules that are out there. So what do I mean by like these rules? So there are certain document, operation, field, argument, fragment validations that are out there that are essentially used to kick off or raise errors to the customer, to the client, if there's any issues with their query that they're sending to the server. So for instance, the GraphQL specification says, a fragment cycle cannot reference itself. And when that happens, obviously bad things could occur, such as a denial of service attack. And so immediately when we were investigating a lot of implementations, we saw that there was one GraphQL implementation that did not support any validations. So anyone who sent a query that was like a fragment cycle query would automatically be able to crash any GraphQL server that's out there. So I do think that understanding what validations are out there for your implementation is very, very, very important, because it highlights the maturity of the implementation as well as what's being checked for. So we know that it's really important to identify what kind of implementations we use. And the way that you can do that is with another tool that we built called GraphWolf, kind of a spin on the other hacking tool out there called WAFWolf, which is used for identifying what kind of web application firewall is behind certain web applications. So GraphWolf will essentially use a bunch of random queries that it will send your server or your implementation to identify the implementation. So it'll send certain queries that will try to instigate errors or responses. And based off of certain conditions that are coming back from the response, you'll be able to infer what implementation is behind the GraphQL server. So for instance, here we have a query at the top here that is looking for directives in the schema, and it actually has a fragment that's attached to it here. When we run this against a Sangria Scala-based GraphQL implementation framework, we can see here that the words fragment A is not used in this query, whereas Apollo will say fragment A is never used. So these subtle differences in just the error or in the response to a particular query are really good detailed information for any attacker looking to profile or fingerprint your GraphQL implementation. The way that it would look like when you run the tool, here you can see that it will automatically even discover which endpoints your GraphQL implementation is running off of as well. And here you can see that it's being able to identify that the DVGA, the damn vulnerable GraphQL application, is built off of Python and Graphene as the implementation. The next tool that we're really proud of as well is the GraphQL cop, kind of like the RoboCop, but for GraphQL. This is the tool that we were hoping everyone would implement in their CI/CD pipeline today, like right now. So what it'll do, it'll essentially run a scan against your GraphQL implementation to highlight certain vulnerabilities that are just out of the box for your GraphQL server. It will check for a whole bunch of things, such as whether or not there are potential GET requests that you can send with your GraphQL server. Obviously, that implies certain cross-site request forgery-based attacks. It will also see whether or not circular or recursive queries are enabled. So there's a lot of checks that it runs, and it'll actually output the severity of those checks. So when we go ahead and we run it against DVGA, the damn vulnerable GraphQL application, you can see here that there's obviously going to be a lot of vulnerabilities. But as you can see here, it's able to identify that field suggestions is enabled. As I mentioned before, get method against queries for possible cross-site request forgery attacks. Alias overloading. This is a way that folks can actually deny, do a DDoS attack against your server. Field duplication, directive overloading, introspection-based circular queries. Again, another denial of service-based attack. So it does do a lot of really great checks, and it only runs it in a few seconds. So it's not that big of a performance hit if you were to embed it into your CI/CD pipelines today. And then the last thing that I wanted to talk about here is the damn vulnerable GraphQL application, DVGA itself. So this is a great sort of playground or dojo for folks who want to learn more about GraphQL and want to find ways to break into it and learn more about how hackers are breaking into GraphQL applications. It's as I mentioned before, built off of Graphene. It is vulnerable by design, so don't go trying to host this in your production VPCs because hackers will find a way into that environment. So run it locally in a trusted network, isolated away from everything else. And as I mentioned before, it's used for educational purposes to teach folks the vulnerabilities and the weaknesses that are behind GraphQL. And with that, I also want to just highlight for folks, we did publish a book called Black Hat GraphQL, Attacking Next Generation APIs. The book goes into way more depth than a 30-minute presentation could ever, and it talks a bit about learning GraphQL. So for folks who don't even know what GraphQL is, we can go through an entire flow, going from zero to hero. It teaches you how to build your own GraphQL hacking lab. It highlights all the other tools that we've built that you can use for your security audits, for your GraphQL implementation. With that, I will pause here, toss it back to the host to solicit some questions. Thank you.
Yeah, thanks, Nick. That was really amazing talk. You show us really a nice bunch of nice tools to check our GraphQL services. I just wondering, in the REST, we have one common common attack type is SQL injection, right? This is also the common attack type in the GraphQL. Sorry, please wait a second, we can't hear you. Okay, now it's okay. Can you repeat the answer, please?
Test 1, 2. Yes, so I heard from you that SQL injection, is that a concern for GraphQL? 100% yes. Just because developers build applications using GraphQL does not mean that it's immune to some of the older vulnerabilities that are present in a lot of traditional REST APIs and other web application frameworks. So yes, GraphQL could very well be vulnerable to SQL injection. It can be vulnerable to cross-site scripting attacks, IDOR. Those things don't go away just because you have GraphQL enabled. While GraphQL is very strongly typed, it does make it a little bit harder to find those vulnerabilities, but by no means are those vulnerabilities gone or made invisible.
Yeah, that's for sure. Do we have any questions? Okay, one from Michał.
Hi, it was a pleasure to listen to your talk. I have one question. Is there any SaaS web application firewall that prevents you for the attacks you mentioned, like those aliases and others?
Yes, so there's a couple of vendors out there that are just now thinking about how to best protect against GraphQL-based attacks. Now, a lot of like the traditional ones that are out there, like Cloudflare, I would recommend if folks have Cloudflare right now to look at their edge workers, because you can actually put in certain edge worker rules to do things that analyze the actual query that's coming in and drop those requests from ever making them to your backend applications. But that's not something that Cloudflare has like out of the box as like a default setting to just say, turn on a bunch of GraphQL rules. You have to actually implement them yourself. I know that there's a couple of other vendors out there as well, Inigo being one of them, as well as ThreadX. All these folks have the ability to actually create your own custom rules as well to protect against a lot of these attacks. But right now, I'd say that the space is a little immature. It doesn't have like a very strong or proven ground that's very user-friendly. So it is fairly immature, and I'd say that there's a lot of in-house development that has to happen, a lot of in-house rule creation that needs to happen. So that's why it's really important to understand the types of attacks so that you can create these rules in your WAF to drop those really malicious or bad-looking requests. But great question. Thank you.
Okay, thank you, Nick. Do we have any more questions? Yeah, one from here.
So by saying what you said just right now and on the beginning also, there's a lot of immaturity in the solutions for testing, for security testing. No like ready-to-go solutions. So would you say that it's still ready for production, like to have open GraphQL API, like for real big applications that need to be secure?
Another really good question. My professional recommendation would be that you should not have anything production or in the way of your critical path for your users if it's not something that's been tested from a security perspective, and is something that is not fully supported from a back-end sort of security team that really understands GraphQL. So you'd have to have like both of those things be true for at least someone like me to be comfortable with launching a GraphQL API in production that's going to support a critical user experience or application. So have like a penetration test or a audit from folks who really understand GraphQL. And then two, have a security team that understands GraphQL as well, who can write those rules, who can at least monitor the traffic coming in and be able to signify when there are alerts or anomalies or malicious requests that are coming in. But by no means, does that mean that folks should not, implement GraphQL in production. But I do think that folks need to be a little more careful with adopting the technology, thinking that it might be secure by default when it really isn't.
Okay, so thank you, Nick. That's all for this presentation. We don't have time for the more questions. So again, thank you, Nick. That was really good presentation.